I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 13th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we have good news. There's a gale in the South Central Pacific with 36-foot seas, aimed reasonably well to the northeast and over a pretty large area. Seas up to 28 foot, a good distance away from the main fetch. This is generating swell that will be radiating north towards, maybe a bit towards Hawaii, but more towards the U.S. West Coast, Central America, Mexico, down into South America. So, we have turned the corner. Good news. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, just like this here. Great example of a trough that's winds pushing to the northeast in the southern branch. Right here is the southern branch of the jet. This is the northern branch. The southern branch lifting north, winds to 140 knots. That's a pretty good speed for the southern hemi. That helps create a clockwise flow aloft, which is the hallmark of low pressure. Also manifests itself down at the surface. And of course, low pressure, if it's strong enough, generates winds. Winds, as they interact with the ocean surface, produce seas. Seas, as they radiate away from the fetch area, turn into swell. And swell, when it hits your beach, turns into surf. So we have some potential, at least in the upper atmosphere. And since we already looked at the wave model chart, we know it's happening down at the surface too. So that is good news. So we get into Monday. The trough moderates, pushes off to the east a little bit. You can see that here. But still, another little pulse of winds maybe on Tuesday, building to, 140 knots. Maybe offering a little bit more potential. And then maybe even a secondary pulse as we get into Wednesday. And then still a broad area of, this trough goes from south of New Zealand almost to the very edge of the Southern California swell window. So all that gives us hope. And here we are, Thursday night into Friday. Still the trough persists. So something could result from that. And then finally, as we get into Saturday, almost a week from now, it pushes out of even the Southern California swell window, but still focusing on Central America and South America. But behind that, the opposite of trough, a ridge starts building with winds pushing to the south. The ice line is somewhere down around 64, 65 south. So that's the Ross ice shelf right here. And with the jet pushing over that will do nothing but help support high pressure. And that's kind of the end of it for a little bit. And we're out 180 hours. So at least we have a good maybe 5 or 6 day window for some swell production, at least from the upper atmosphere. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds. There's actually 2 storms, 50 knot winds right there. Another area of 50 to 55 knot winds there, and actually a third gale in between that. But this system here off to the far east, all winds are pushing south. The one in the middle here, very weak. This is the main event here. 50 to 55 knot winds with 35 to 40 knot winds over a very broad area. Just eyeballing it, that's probably 1,000 nautical miles. We could do the math and figure it out, but that's a lot of fetch aimed from the southwest in our general direction. As we get into Monday, it shifts east, and notice there's still a small area of fetch aimed to the northeast, but the broadest area here is aimed southeast, of no interest. But then still a broader area behind that of 30 to 35 knot winds aimed well northeast. That would generate 12, 13 second period swell, something like that, which is probably not optimal, but it's better than nothing. We'll take it. The same sort of thing continues into like Monday night, then it fades out. A second system develops with 50 to, you can see it just barely under the tag here, 55 knot southwest wind. So there's hope there. And then it starts, the low itself starts falling southeast, but you can see just barely under the tags. There's wind aimed off to the northeast there. Then the whole system crashes south. A third system develops Wednesday night, again with 40 to 45 knot east to west to southwest winds. And then it too it's like gales rotating around a central core way down here. They call that a complex gale pattern. And then as we get into Friday night, yet more fetch here, 30 to 35 knot, pushing off to the northeast, starting to move out of the swell window. And then a whole bunch of fetch behind that, all aimed pretty much off to the east. We're into Sunday. And then another system right on the edge of the swell window as we get 180 hours out. Notice low pressure cut off low up here, kind of driving the jet further south. So we'll see. Let's go take a look at the effects of this wind on the ocean surface. So we're going back in time, first to Wednesday night. 0Z Thursday is about is exactly 5 p.m. on last Wednesday, California time. Small gale developed, producing 28, 30-foot seas right off the edge of the Ross ice shelf, and sort of eased off to the east. Not a whole lot of swell is expected from that, a foot or something like that. Another system, actually, let's go back, developed under New Zealand. This is also Wednesday night into Thursday morning. Nothing huge. Peak seas here at 36 feet, but over just such a tiny area. Can't get much swell from that. And it faded off. Where are we? Then things sort of mellowed out, but you can see the pattern starting to develop as that trough built aloft. That's where you wonder, why are we so focused on the jet stream? Well, you can literally see the trough was like doing this thing, and right underneath it, you see the wave models reacting accordingly. So late Saturday night, the new gale started forming, 30 knot winds building to 30-foot seas building to 32 foot to 34 feet as of this moment. Now let's go look at the model. This is hindcast data, the 0Z. That is the base truth, okay? What is happening right now, you notice all these as we go back in time, they're all 0Zs. Then we go to the 0-hour hindcast, if you will. And then here we are. The first frame of the model is the 0-hour hindcast, right? So what we do is we collect, every time the model runs, every 6 hours, we collect each of the very first frame of that model, and we stack them up. And so there's hindcast data, so you can go look and see what's happening. And then elsewhere on the site, well, maybe I can just pull it down here a little bit. Under the altimetry section, I'm not going to get into all this. Then there's actually the satellite model overlays, so you can compare what the model said to if the satellite made a pass right over there to what it actually says to see how accurate the model is. Actually, most of the time, the model does a reasonably good job considering how little altimetry data we have and how there's literally very few sensors out in all this open ocean, but it does a pretty fair job at least a couple days in advance. All right, so anyway, moving on. Sunday night seas build as we get into 06Z Monday. That's 11 p.m. Sunday night, California time. 39-foot seas, not over a huge area. This thing at one point the model suggested 50-foot seas. Now something less, but still, as we get into Monday morning, some of this is all aimed off to the east. A little bit more fetch back here. Remember, there was that 30, 35 knot winds with seas to 30-foot building. And secondary fetch, if you can call it that. And then as we get into Tuesday, things fade out. But another system, we saw that on the models, starts building. This is actually Tuesday night. 30-foot seas aimed off to the east. It's more this fetch back here that's aimed more northeast. This would be focused more in this area. This area back here is the California fetch. We'll say 27-foot seas, something like that. Notice this is all falling southeast, aimed southeast. Yeah, great. 37-foot seas, but isn't doing anything for us. It's penguin surf for sure. All right, as we get into Thursday, then another fetch, 30-foot seas. But the interesting thing is, wind over the same area of ocean day after day after day. It doesn't take much wind because if you already have, well, let's just go back here. So let's say you got 26-foot seas here. The fetch is dying, but then you get another fetch right over it with, 40-knot winds. It's that 40-knot wind starts playing on the 20-plus foot seas that are already there. It just starts imparting more energy to those pre-existing swells. So the thought is there's just going to be this steady stream of swell pushing north for 5, 6, 7 days. Who knows? Given that we've gone through almost 2 weeks of no surf, this is a godsend. We'll take it. An even fetch As we get into Saturday, what was that 20, 22, 24, 26 foot seas? Yeah, nothing too interesting. You can literally see, remember the trough in the jet stream? Boom, right there. Plain as day, real obvious, another reason to watch the jet stream. It tells you, if all you have access is to jet stream data, you can get pretty rough ideas, say, oh yeah, whether a storm's going to form or not. All right, so, and we're into Monday or Sunday night, a week out, things settle down for sure. All right, wind swell. Low pressure, believe it or not, off of Oregon. There was rain this weekend, I believe, in Cape Mendocino, that area. South winds, even as of, well, let's just go to today, to now. Southwest winds, maybe from Point Arena northward, we'll say. Kind of dead air in between, and all the north fetch finally is getting it's down in Southern California, giving an opportunity for water temperatures, the upwelling stuff to back off. California water temperatures are coming up, but as we get into, here we are, Tuesday, low pressure moves out, high pressure nosing in, the gradient starts again. 15, 20, 25 knot winds off of Central California. I'm looking over here, Hawaii. Trades, but nothing more. Maybe some weak wind swell. But as we get into Wednesday, here we go. The full high pressure summertime gradient thing. 20, gradient, high pressure here, low pressure inland. The difference between the two tightens up the isobars. That's these lines here. And that generates wind. 20, 25, almost 30 knots a Wednesday morning, continuing into Wednesday evening. For sure, wind swell there. And notice wrapping the whole way into Hawaii, probably wind swell into the Hawaiian Islands as well. Thursday, goodbye. Warm temperatures for Golden Gate northward, 30 knot north winds. Another massive upwelling event. Fetch the whole way into the Hawaiian Islands. Wind swell for sure. 35 knots up Cape Mendocino as we get into Friday. Maybe some south wind starting. Typically you get this where it's really strong up north. Low pressure, you can almost see it right here. The model doesn't show it, but you get that south wind effect along Central California. And that might be good for help warming up water temperatures a little bit. Continuing Saturday. Certainly a good day for wind swell Saturday along South and Central California. And the swell from down south will not have arrived by then. So it's all kind of a gift at this point. Again, strong high pressure in control as we get into Sunday. More wind swell, if anything. We're at 180 hours out. And fading wind swell for Hawaii. So wind swell, probably the name of the game this week until some real swell starts showing up. The first tiny pulse of swell from the very first mini low that we saw should arrive Tuesday or Wednesday. Tuesday, Southern California. Wednesday, Central North California. But we're talking 1 foot at 17 seconds. So not, a foot and a half, maybe 2 feet. Maybe best spots 2.5 feet on the rare set. So don't get your hopes up yet. It's not till another week or so after that we start getting some decently rideable surf. No rain, no snow expected. This is Squaw Valley, but we're just using it as sort of a rough reference point. The point being, if you're hiking Pacific Crest Trail, John Muir Trail, snow levels dipped a little bit. They were down earlier in the week. They're now, the freezing line is somewhere around 12.5, 13,000 feet. And then extreme heat is forecast. Details a little unhazy right now, mainly in the Central Valley. Thursday, Friday, Saturday, snow level or freezing level way above 14,000 feet. That will certainly help melt off snow on the high passes on Pacific Crest Trail. I don't really know the status of how clear they are right now. I'm sure it's not horrible given how low the snow levels are right now. I mean, there's only like little pockets at 9,000 feet today, and it's all completely passable. And it was amazing how quickly the snow has melted off. So just a bit of data there. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and, of course, El Nino or La Nina, the El Nino Southern Oscillation. We're always interested in the active phase of the MJO. The Madden-Julian Oscillation comes in 2 phases, active and inactive. The MJO is this weather oscillation that rotates around the equator from west to east. You'd think it would go from east to west, but no, it goes from west to east. And it on one half of the planet, it's the active phase. On the other half, it's the inactive. The active phase is the one we want. The active phase basically is like a ball of low pressure traveling from west to east across the Pacific. When it does that, it creates storminess on the equator and also north and south of the equator by feeding energy into the jet stream. Feeding energy into the jet stream helps create troughs that we talked about earlier, and the stronger and the more energetic the troughs, the better the storm pattern and the better the odds for surf. So, and of course the inactive phase does the exact opposite, shuts down energy transfer to the jet. It's like a high pressure system. You get a lot of high pressure and wind swell, but that's about it. We don't want that. We want the real deal. Long period swell from storms. All right, so we're looking for signs of the active phase of the MJO. This is data from the TAO buoy array, series of buoys strung across the equator. This is used for monitoring El Nino. The active phase of the MJO, since it's like a low pressure system, it stomps on the trades. It can reverse trades. Trades on the Pacific blow from east to west. Look at the arrows here. This is the 5-day mean wind speed and direction. The buoys are on the equator, 5 degrees north and south of the equator the whole way across. They pick up the data, and you can see the arrows here out of the east. Pretty strong over the East Pacific, moderately strong over the Central Pacific, moderately strong over the West Pacific. We call this the Kelvin wave generation area. The West Pacific that's the, right there, that is the date line. That's the equator right there. Draw a box in your mind's eye from 170 west, 5 degrees north and south of the equator, the whole way over to the far edge of the West Pacific. When the active phase gets here, it's low pressure, it stomps on the trades, it can reverse the trades, and that's what we want for the energy, not only energy transfer to the jet stream, but also to take warm water that's perpetually pooled here, start pushing it off to the east, not on the ocean surface, but under the surface of the ocean. It's called the Kelvin wave. Eventually that will erupt off of Ecuador. It takes like 3 months for that ball of warm water to make it across the Pacific. Once it erupts, the trades will pick it, start pushing it off to the east, and then that can significantly change the jet stream pattern because warm water across the whole Pacific creates a lot of evaporation that feeds the storm machine, and that's how you get El Nino. And we all know that El Nino produces surf. All right. But it is the anomalies, not the mean wind speed, the anomalies, differences from normal for this time of year. Winds normally blow pretty hard out of the east trades in the East Pacific. You can see here by looking, the arrows are like, they're not really going anywhere. We're just 5 degrees north and south of the equator. So this is pretty much a normal pattern. In the Central Pacific, normal. What we want to see over here is these arrows not go from the east like that, but go from the west. That would mean the active phase of the MJO. So right now, looking at this, we'd say no active phase of the MJO. If anything, maybe the inactive phase or a neutral pattern, something like that. Let's go look at the forecast for the next week. Okay, here we go. This is a strange chart. Whole planet on one chart. So we got to pick out the West Pacific. West Pacific starts about 135 east, so just draw a line right the whole way up the chart in your mind's eye there. Kelvin wave generation area starts there, goes to about 170 west right there. Okay, and then the Pacific goes the whole way to Ecuador, which would be right about here, about 80 west. You can see a little seam in the model right there. All right, the blues are easterly anomalies. That would mean inactive phase of the MJO. So you see up here, this was like the active phase, westerly anomalies in May, early part of June. Now, maybe the inactive phase or something else going on. But the good news is it's only 1, 2, 3, maybe 4 or 5 days in duration. Then westerly anomalies pick up again. So, not a strong MJO signal at all is what we're seeing. Let's go further. Outgoing long wave radiation, another component of the MJO. Remember, the MJO is like, the active phase is like low pressure, the inactive phase is like high pressure. All right, so what are we looking at here? Equator is right there, South America there, Central America, Mexico there, there's Hawaii. Dateline, 180 west, right there. So the Kelvin, and there's New Guinea, Philippines, Kelvin wave generation area right here. So we got these yellows. What's that mean? Those are positive anomalies. This is outgoing long wave radiation. Fancy words for sunlight reflectivity off the ocean surface. More reflectivity of the normal. So we'd call that the inactive phase of the MJO. It's like high pressure over this area. That's supposed to continue for 5 more days, fading to neutral, and then maybe the active phase 2 weeks from now, per the statistic model. The dynamic model, there it's in sync, also saying inactive phase, going neutral, but just staying neutral 2 weeks out. So a bit of disparity here. Let's dig a little deeper. Phase diagram charts, weird looking charts here, but this is the statistic model. This is the dynamic model. The MJO travels around the equator from the Indian Ocean over the maritime, from west to east to the maritime continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, and the closer to this circle, the weaker it is. So you really want to see the active phase somewhere out here, and preferably right here in the West Pacific, way up here, but that's not happening. So the active phase, very weak over North Africa. The 3 different forecast runs from the statistic model saying, yeah, something meandering around in the Indian Ocean for the next 2 weeks. Very weak. The dynamic model, not even that good, just saying pretty much staying where it is for the next 2 weeks, and very weak. So no hope from either here. So if that doesn't work, let's go further out in time. Of course, here's the danger with that. I don't believe a model 5 days out, much less 40 days out, and that's what this is. 5 days per panel, 1, 2, 8 of them, you can count them. Each panel, South America, Central America, there's the equator right there, the Galapagos, that little dot. Hawaii's not even on here. New Guinea, Philippines, Kelvin wave generation area right here. This is jet stream level support for precipitation. Yellows, oranges, not favorable for precipitation. So this suggests the inactive phase over the Kelvin wave generation area. That's what we saw on the other statistic model. And that pushing its way across, maybe a little hint of a weak active phase trying to organize from maybe June 23rd into about July 5th or something, 8th. But that seems even less likely. Another very weak inactive phase behind that, and then another very weak active phase behind that starting in the 4th of July. That's probably the more interesting one or consolidated one, at least active phase. So we'll call it June 3rd into about the end, July 3rd into the end of July. But overall, a suggestion here of a very weak MJO pattern for the next 40 days. CFS model, it's a dynamic model going out 1 month. Pretty much the same sort of deal here. Whole planet on one chart, date line right up the middle. Kelvin wave generation area starts about 130 east, so right there, to about 170 west. So we're just looking in this area here. The blues are easterly anomalies, so this isn't precipitation, this is east-west component of the wind, suggesting inactive phase of the MJO. Actually, it shows this red thing here. That is a equatorial Rossby wave. Okay, we're not going to get into all that, and I'm not an expert, so I'm not going to, try to fool you into thinking I know all this stuff. But the solid dark line here is the active phase of the MJO. Notice, in the dotted contour, this is the inactive phase. This is back in April and May. Inactive phase made it from west to east across the Kelvin wave generation area with the easterly anomalies. Active phase here pretty much ended about 2 days ago. You can see it slipping across and dissipating. Now we're in dead air. East anomalies for 5 days. West anomalies set up, not really driven by anything, just sort of a base state westerly pattern. Then sort of a mixed west pattern as we get into late June, early July. West winds in the west Kelvin wave generation area, east winds in the east Kelvin wave generation area, a mixed pattern. And then when in doubt, we don't see anything near term, let's look 3 months out and pray that we get something to tease us. And that is this, the 3-month CFS model, 850 millibar wind anomalies. Again, east-west component of the wind. The past performance is down here, Kelvin wave. So date line right there. Kelvin wave generation area, West Pacific starts right there. The box in your mind is right there. pretty much dominated this whole season by easterly anomalies, except right in here. That would look like a pretty good active phase of the MJO that might have generated a Kelvin wave. We all know that that Kelvin wave is in flight, but I just thought I'd say it anyway. All right, looking forward. Here's our little bit of east anomalies in the Kelvin wave generation area for the next 5 days. Then back to light west anomalies. Maybe a little bit of a break with the inactive phase from July 7th into about July 31st. And then after that, west anomalies, but only limited to maybe the western half of the Kelvin wave generation area with easterly anomalies in control otherwise. So this model, well, let's overlay the MJO and then we'll talk the long-term strategy. And right, so here we go. Active phase of the MJO in the Kelvin wave generation area from, we'll say, June 18th through about July 15th. The dotted contour, inactive phase, easterly anomalies, not good for surf production in July, most of July. And then as we get the end of July, August, supposedly a pretty solid active phase of the MJO with westerly anomalies. But this model has overhyped the heck out of all these active phases. They look monster big 2 months out. And then here's what really happened. You get 1, 2. So here's that active phase of the MJO in April. It did create a Kelvin wave, 2 of them. That's, and you notice the westerly anomalies, they're not strong, but they made it the whole way, whole way across the Pacific. We're not even really seeing, nothing as cohesive as that. I'm beginning to think that the Kelvin waves that are in flight are probably an anomaly, a one-time event. So let's go on. Low pass filter. All right. So what is this? This is a sort of base state of the oceans. Dotted contour is high pressure. This winter we were dominated by La Nina, which is the effectively high pressure over the Kelvin wave generation area. And you can see 1, 2, 3, 4 contour lines. The good news is that is fading down to 1 contour line today, supposed to majorly recess to the far, almost to California. But then as we get into August, it looks like it's going to rebuild. The low pressure bias here, which was holed up in the Indian Ocean, is trying to make it into the core of the Kelvin wave generation area. It's about halfway there. It'll make a little more progress into the end of July, and then it backtracks. So this model, the CFS model, has been suggesting sort of a return of La Nina this fall and winter. We've been trying not to believe it, but we're out of the spring unpredictability barrier now. And in fact, it does look like maybe not full La Nina, but something that sort of smells like La Nina coming back in the fall. That does not bode well at all for precip in California, at least into the January time frame. Typically, if you're going to get a change from La Nina to El Nino, it'll happen. If it's a strong change, it'll happen like the late January, February time frame. But that's only strong ones. If it's weaker, it's more like the May, June, July time frame, or even later after that. So we watch this. It gives us some signs. We've been trying not to believe, because this model has been saying some sort of La Nina-ish type return in the fall. But now we're seeing enough evidence to say it's probably right. The model has not wavered for 5 or 6 months now, so we're going to say that it's probably on track, and NOAA is sort of indicating the same. All right, so what's going on in the ocean? Enough of this MJO stuff. Let's look, and this is really the El Nino La Nina indicator. Right now, okay, this is the East Pacific, this is the West Pacific. Data again from the TAO buoy array. These are the anchor lines. You can see one actually right there. Anchor lines on the buoys, holding them in place. The X's are sensors on the anchor lines. They collect subsurface water temperature data, relay it all up to Maryland or somewhere. It gets mashed through a supercomputer with a model, and then you get a profile of subsurface ocean temperatures. And you ask, well, why would you want to know that? Well, we talked about Kelvin waves, and those being the things that help start El Nino. So that's what we're looking for. We're looking for warm water, 29 degrees centigrade. It's all in centigrade here, but that's pretty warm water. We want to watch it pushing off to the east. 28 degree isotherm. We watch that. It's It's at 160 west today. Last week it was at like 159. I think it made it to about 156 or 155 at what point. But it's sort of just holding steady. And there is the 24-degree isotherm line is pushing the whole way into Ecuador. This winter, it only made it to 140 west. So this is looking much better, but it is no better than what it's been for past couple weeks, maybe a month or more. Let's look at the anomalies. Differences from normal for this time of year. Still painting a pretty good picture. A building area of warm water in the West Pacific 2 degrees above normal. We need westerly anomalies and a decent active phase of the MJO to take warm water here, start pushing it to depth, and then you can see this is a Kelvin wave. It was just like this, warm water in the West Pacific, but that active phase in, when was it, April and May timeframe, pushed it. It takes three plus months to make the journey across the Pacific. It is poised to impact, if it is not impacting already, the area around Ecuador and the Galapagos this date. We'll get a little bit deeper into that in a minute. Here's another model, same data. Now this is showing, notice, there's a little pocket of 2-degree anomalies here, but not making it to the surface. This model suggests actually a clean break between one Kelvin wave pushing in. We're not calling this a Kelvin wave, though we're kind of trying to monitor this line here, and if we see this moving off to the east, then it'll be declared a Kelvin wave, but probably a little bit premature. We haven't seen a strong enough active phase of the MJO to really put this stuff in, this warm water, in motion yet. Sea surface height anomalies. What's that mean? Well, Jason 3 satellite beams altimeter, beam down, I think it's radar actually, down on the ocean surface to see how, you can use it to see sea heights inside of storms. We talked about that earlier. But it also can give you they know what the exact height of the sphere of the ocean is with no waves in it, no wind waves, and you take out the effects of the tide. And that's what this is. We're looking, because warm water at depth expands. When it expands, it creates a bump on the ocean surface. Likewise, cold water at depth contracts, creates a little divot on the ocean surface. We're looking at the heat balance right here, the equator, right? Okay, Chile right there, South America, Peru, Galapagos there, Central America, Mexico, Baja, Hawaii right there, Dateline right there, New Guinea, Philippines, 5 degrees north and south of the equator. So there's 10 south, so 5. We're just looking in this box along here. We see height anomalies here, meaning there's some warm water here, but even not as much as there was a month or two ago. We see pockets of warm water along here. We actually see a little bit of or negative anomalies suggesting cold water here. So this sort of syncs up pretty well with this guy here saying warm water in the west, warm water in the east, little pocket in between. See? Warm water in the west, warm water in the east, little pocket in between. So just another way to confirm, taking one source, just like reading the news. You read one source, and if you only read that one source, you're kind of hosed because you're stuck with their opinion. So you take multiple sets of data, compare and contrast it, and then try to find what is the middle line between it. Some of these sources are pretty, the statistic model and the dynamic model vary widely in their opinion, but the truth of the matter is somewhere in between. It's not, some models actually do pretty well, but, generally I'd say look at all of them and average them together in your mind. Upper ocean heat anomalies, same deal. East Pacific here, West Pacific here. Oranges and reds are warm temperatures, blues cold temperatures. You can see this is the La Nina signature back in August, September, October. Really cold water here in the East Pacific, south of California. Wonder why there was not much precipitation? Because due south of California on the equator, and it's really weird that a patch of water that's like, 200 miles, it's more than that, what is it, 10 degrees wide, 600 nautical miles in coverage north and south, and then maybe thousands in miles east and west, but that little patch of water affects the precipitation thousands of miles north and south of it. Drought conditions in California driven by this. Now here is remember we talked about that active phase of the MJO in March, April, May time frame. It hit this warm water, west anomalies, 1 Kelvin wave there, second Kelvin wave there. They sort of stalled around 90, but we think they're making it the whole way. Ecuador's at 80 into Ecuador now. Also notice here is that we think maybe is another Kelvin wave, but probably not. Hard to say. We're keeping our eyes on it. Anyway, this gives you a better perspective over time. Sea surface temperature. And here is another little bit of bright news. Okay, Chile, Peru, Ecuador right there. The Galapagos right there. The equator right along there. And what do we see? The yellows and oranges are warmer than normal. And again, it's only 5 degrees north and south of the equator. So let's say like from here up to about the top of this image, or you can use this image from the bottom up to about here. And what we see is warming temperatures, and this is much warmer than last week off of Ecuador, the Galapagos, and getting caught by the trades drifting off this way. This is in the Niño 1.2 region here. The Niño 3.4 region, the official El Niño monitoring region, starts south of California the whole way out to almost the date line, 170 west out here somewhere. And you see warming temperatures there as well. So you get the sense that, well, for sure the Kelvin waves are erupting. That's what's causing this. And warm water from that is drifting. If it's not the Kelvin wave itself doing it, it's drifting, or just trades are reduced in this area and you get sun warming here. And that's good news. You can still see, though, the effects of massive high pressure that's been causing upwelling here off of California. Notice even in Northern California, temperatures a little bit above normal now too. Okay? Anyway, so ocean surface temperature trying to return to normal, but we still got this big pool of cool water here. That's not La Nina, but that's sort of the ancillary effects or symptoms of La Nina. But on the actual equator in the official monitoring regions, things looking much like normal, at least for the moment. Trend for the past 7 days, the reds in that same 5 degree north and south area on the equator, warming along the Galapagos off of Ecuador, or slightly along Peru. I mean, this is not big warming. I mean, normally we would sneeze at this and go, yeah, whatever, big deal. But given that it's been so cold and that La Nina has been so pervasive, any warming is good news. Anything that gets us back to normal. Now you see a lot of warming up in here, but that's not the same as warming here, and it doesn't have the same effect. This is more than likely just warming due to lack of winds, due to massive, strong, in the center of a high pressure system like right here. That's probably what's driving all this. Oh, and you can also see warming developing along California too. We'll take it. Now, this doesn't mean that temperatures are warmer than normal. It just means that it's warmer compared to what it was 7 days ago. So 7 days is not much of a trend. 3 or 4 months, then we're talking, but we're nowhere close to that. And then the backed off view. Again, our warming off of Ecuador out here along the equator. You know, it's not solid warming. It's just almost normal. I mean, there's the yellow. The beginning of the yellow is normal. The gray is new. Well, I don't know if there's any gray on here. It's either one or the other. But so I guess that is the gray right there. So basically neutral to slightly above neutral in the Niño 1.2 region right here, and the official El Niño monitoring region right out here. So that's good news. At least the death of La Nina seems apparent. Sea surface temperature trend in the Niño 1.2 region. Well, we've been hanging about 3/4 of a degree below normal for, it seems like, forever. Today or yesterday we popped up to, getting almost normal today, 163 thousandths of a degree below normal. So yeah, 1/10.5 below normal. So almost normal. But it's not the Niño 1.2 region we're really interested in. This area is noisy. The official El Niño monitoring region. Hooray! We are finally positive. As much as we're negative in Niño 1.2, we're positive almost the same about 162 thousandths of a degree above normal. But we've only been positive in little spikes since May 2nd, so a month and a week or something like that. And even then, we had some dips negative. But the trend, you can see, since March, steadily upward, suggesting, again, the complete demise of La Nina. And is La Nina still present in the atmosphere? Well, we look at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific. Darwin is sort of in the Indian Ocean. If Tahiti has lower pressure than Darwin, then that suggests either the active phase of the MJO moving over to the Pacific, and if it continues long enough, then that suggests El Nino. But if Darwin has the upper hand and the index goes positive, then that means La Nina. Today, our daily value plus 4.22. But you see, we've been pretty good negative for a while. When did that start? Probably around in here, May 24th. So that would be the active phase of the MJO. Now maybe it's fading. The 30-day average, minus 1.76. That is good news. That is the most negative we have been in a year. Easily a year, more than a year. So that suggests a return to at least normal conditions in the Pacific for the moment. And the effects of the active phase driving us from plus 7.65 down to minus 1.76. So that's good news. 90-day average takes all the noise out here. If this is the active phase, inactive phase indicator, this is the El Nino, La Nina indicator today, plus 1.34, which is nothing. Looking where we were a month ago, plus 3.40. Back at the peak of La Nina, we were at plus 15. Over here, we were at plus 19. So we went from plus 15 to 1.34, and we actually, our lowest was 1.06 on June 9th. So we're trending in the right direction. But let's go look at the and let's look at a graph at this first, and then we'll go look at the long-term outlook. 30-day moving SOI on a graph. Well, we were in like a weak El Nino back in 2019. In 2020, we started getting more and more positive. This is La Nina. Remember, here's the 0 point, the positive value of the Southern Oscillation, peaking at about, well, we said 19. This is actually a little different set of data, but close enough, plus 20. Today, negative a little bit, so we're hanging right around in neutral. But where are we going to be 3, 4, 5 months from now? So we go look at this, the CFS version 2 model, the official forecast for the Nino 3.4 region. That's the official El Nino monitoring region. This model suggests, yep, here we were, negative 1.25 degrees back in October, the end of October. Temperatures steadily warming to today, where we're neutral, pretty much holding into, we'll say, mid-July. But then remember, we talked about this double dip La Nina, return of La Nina, at least water temperatures. So here is 0.5 degree below normal. This is the La Nina threshold. This model, this model had suggested temperatures is holding right about 0.5 degree, but now it's trending more down to maybe minus 0.7 degree. But it's only in that threshold for, we'll say, the month of October, November, December, and January. November, December, January. That's only 4 months. You need 5 consecutive months to get you in La Nina, plus a bunch of other stuff. So officially, NOAA's not thinking that we're going to go into La Nina. We suspect probably not, but the hangover from La Nina will continue. We expect pretty good drought into the through the bulk of winter, but somewhere when you get into February, March, there could be a change. We talk about that change in season there. Not suggesting we're going to El Nino, but by then, for sure, the La Nina thing should be dead. The real issue is what's going to happen in here in terms of precipitation for California. We don't have any feeling that anything good is going to come from it. We think, again, all the precip's going to get shunted to the north. It'll be up into North Oregon, Washington, that sort of thing, which isn't great for California reservoirs and rainfall and skiing and snowboarding and all that kind of stuff. But that is a reality that we might have to deal with. All right, so good news first. There is a storm in the southern hemi, and it looks like there's more to come. A long run of swell, not huge swell, but at least decently rideable swell looks possible starting, maybe, let's say a week from now, and then continuing for a week after that. But prior to that, tiny little small southern hemi swell for California starting Tuesday, Wednesday sort of thing. And by tiny, we mean tiny. Like, if you can see it and you can stand up on it, that's it. But that pattern should be improving steadily through the week into the weekend. And then once we get past next weekend, things should probably wake up pretty good for a whole week after that. And then it kind of looks like we're going to fall into a hole again. Okay, so that gets us, we'll say 2+ weeks out, 2.5 weeks from now. Beyond that, well, a little bit of inactive phase, and then maybe another run, July, sometime after July, maybe. Beyond that, well, it looks like, again, like we were saying, the double bounce La Nina thing. So we were thinking we would get out average swell sort of thing for not the fall, but maybe the winter. But now we're thinking maybe back to, on a 1 to 10 scale, with 10 being epic, maybe a 3 or 3.5 or something like that. But we'll see. That CFS model, it's doing a pretty good job. I hate to think that it does overstate it a bit. Okay, so maybe it won't be as bad as it says, but still, we're not super optimistic for the winter. Anyway, that's it. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. Ring the bell. You'll get automatic notifications we post the video. If you don't want to do it, that's cool. You can just go to stormsurf.com. On the top page of every site, on the top of every page in the site, you get a link to the video. Go to it there. Also, if you have questions, comments, anything, write it on the YouTube channel there, and we will reply. Sometimes we get some really good questions, some good discussions going, so don't be shy. And it helps the algorithms a little bit too. So, not like we're making any money out of this. It's really for fun and for your enjoyment and for people that want to stay in the know. That's what we're all about. So thank you for watching. We'll do this again next week. Same time, same channel. And thanks for watching. See you then. Stay safe.